Okay, so question number 32, I made a little mistake in it. I could not properly read it. So actually it states, uh, the original question is, uh, 3 newtons to the left. Oh, I didn't read this one. So there is a leftward direction as well. Okay, so 3 newton left. It means, okay, so on the right side we have 11 newton force. On the right side we have 11 newton force, and on the left side we have 5 newton force. So the answer should be, the answer should be 3 newtons. So we know the resultant answer is 3 newtons, and on the right side we have 11 newtons, and we don't know how much is the, how much it should be on the, how much amount of force should be added on the left side. So I'm gonna put x. So now rearrange these. If I move x to this side, our required answer is 3 newton. Okay, so there is little, okay, x is greater than 11 actually. X would be greater. Yes. So okay, now we can move 11 to the right side, then it would become 11 plus 3, which is equal to 14 newtons. So on the right side, if there would be a 14 newton force, on the right on the sorry on the left side, if there would be a 14 newton force, and on the left side there is an 11 newton force, then we can say that the resultant force is 3 newton acting on the left side. So already we have 5 newton force. How much force should be added to make it 14 newton? So we are going to add a force of 9 newtons. If a 9 newton force is added to the left side, then it would become 14 newton. Overall it would become 14 newtons. Okay, so our answer is this one. Previously I made a mistake, I didn't learn about the left word. Okay, in question number 33, the diagram shows a firework rocket. Okay, as the rocket flies through air, the forces acting on it, like there are p q r s type of forces. There are few forces which are acting on the rocket, like p q r s are the forces. These forces are, okay, are weight, thrust, and air resistance is something like this. Like this is thrust, this is weight, this is air resistance. What are three forces? What are these three forces? Okay, so we can say weight is actually r. Weight is always acting in downward direction, so we can first mark weight. So our two options are these two. So weight is acting in this direction. Okay, thrust, and then air friction. Air friction is s, because it is like the rocket is going, it is always opposite to the direction of motion. Rocket is, if the rocket is going in this direction, then the weight would be the frictional force would be acting in this direction. So S would be our frictional force. Okay. Okay, so S is our air resistance. I think I made a mistake. Is this a R? This is R. Okay, okay, okay. I thought it's P. Sorry. Okay. So what about thrust? Thrust is this one or this one? Up thrust. Okay. Thrust is okay. Thrust is, I think so, Q up thrust. So thrust is actually Q. So Q is somewhere here and here. So we are left with this is our correct option. Okay. An object next is number 34. An object has a mass of 15 kg. Okay, the mass is given, so we can mark it like this. The mass is 15. It is pushed horizontally by a force of 14 Newton. So force is 14 Newton. The frictional force is 10 Newton. Okay, so 10 Newton is the frictional force. What is the acceleration of the object? We know by we already solved such type of problems. Resultant force is driving force minus frictional force. So we know that it is m dot a, which is equal to applied force is 14 Newton and the frictional force is 10 Newton. So mass is 15 kg. Mass is 15 kg and it is equal to 30 newtons. Okay, so now moving 15 to the other side, it would be like 15 2s are 30. So acceleration is 2 meter per second square. So our correct option is this one. So this is our correct option. Okay, now let's move to number 35. The propeller on a boat pushes water backward with a force of 2000 Newton, which is given like this. It's a propeller which pushes the water in backward direction and the force applied is 2000 Newton. The boat moves through water against a total resistive force. So resistive force is 1800 newtons. So this is the resistive force. The propeller is acting in this direction. According to Newton's third law, what is the forward force of the propeller due to water? So according to the Newton's third law, action and reaction are equal in amount but opposite in direction. So if we just consider only propeller, the scenario of propeller, the applied force of the propeller is 2000 Newton. So it should be 2000 newtons because action force is 2000 Newton. Then at the same time reaction force would be 2000 for this force. So it's an action force, so reaction force would be 2000 and it would be in this direction. then there is a confusion that why do we ignore this one. Actually this is a resistive force, and if we consider 1800 newtons, that would not be added to the propeller's backward force, it would be subtracted from the forward force of the propeller, that can give us 200 newton as a resultant force. So like the question is only for the newtons, regarding the Newton's third law, so we are going to consider only Newton's third law. So action force is 2000 newton, so reaction force would also be 2000 newton. Number 36, an engine pulls a truck, oh sorry, an engine pulls a truck at a constant speed. Constant speed means acceleration is 0. Acceleration 0 means resultant force acting on it is also 0. Okay, acceleration is 0. The link between the truck, oh sorry, the link between the truck and engine, the link between the truck and this is the truck and this is the engine brakes would be somewhere here. The driving force on the engine remains the constant, okay, because the velocity, okay, because there is a balanced force, okay. What effect does have on the truck and engine? What effect does have on truck and engine? The first option is about truck and E for engine, suppose. The driving force on the engine remains same and the truck slows down. Like the truck slows down and engine, I think so. So the question is, like when the link is here, when this link breaks, okay, this is the engine portion of engine, this is actually the portion of engine, and this one is actually the truck portion. This is the truck portion, okay. So when the link between engine and truck breaks, you can see the truck would get released from the engine and the truck would no longer be pulled by this engine. So after few seconds the truck would be in rest state, because there is no pulling, nothing is pulling it. So truck is going to be to be slow down, or maybe, like, yes, it would be slow down, yes, that's damn sure, because immediately it can't stop. Due to inertia it would carry on its motion for a certain moment, for a certain amount of time. What about the engine? Like the engine is dragging this truck, so when this mass is released, the load, like the load from the engine is decreased, so engine can get speed up, so it would speed up. So the possible answers are slow down, the truck would get slow down, and engine would speed up. Okay, this is the possible answer. Okay, a car travels along a road. The driver stops the car by pushing his foot brake on the brake pedal. What does not change if he pushes harder on the brake pedal? Okay, the braking distance, the braking force. Yes, the braking force increases, so it would be affected. So braking distance, if push, stopping distance doesn't matter. Thinking distance is not linked with your feet. So thinking distance is the first non-possible thing, because your feet and brakes are not linked with your feet. Stopping distance is no. The braking force. Okay, the question is what does not change if he pushes. Oh, okay, sorry. So actually the let's let's talk about those things which are affected. So braking distance is affected when more force is applied on the brake. The braking distance will reduce, the braking force will increase, it both are affected. The stopping distance will be different, and there is only one thing which is in your brain, that is called thinking distance. It is not affected, it is unaffected. Okay, next is an aeroplane, aircraft flying aircraft flying on a constant height is gaining speed. The force is acting on it like this. Lift due to wings is like this. Weight is acting in direction. This is the engine force, and this is thrust due to the thrust, and there is air friction is acting in downward direction. Which row is correct? Okay, the weight, let's consider things which matters. First of all, flying at a constant height means neither it is going in upward direction or going in downward direction. So these two things, like lift and weight, looks equal. Neither the lift is large. If the lift would be large, it would go in upward direction. If the weight is large, it would go in downward direction. So flight at a constant height means its lift and weight both are almost equal. There is no difference. That's why it is flying at a constant height. Now, okay, what about the thrust due to engine and about air friction? There is one more thing in a question. It is, it states that it is gaining speed. It means its speed is increasing. Increasing means that this thing is larger than this thing, means thrust is greater than resistance. So that's why the aeroplane is gaining, speed. So what are the options? Thrust is greater than, so our possible answers would be that lift and weight are equal, and thrust is greater than resistance. So these are our possible options. Let's match them with the given answers. Okay, so let's see the option number A. In option A it states okay, lift sorry, lift and weight are equal, so this option and this option are correct. These are vertical forces. And what about the horizontal forces? Tension, sorry, thrust is greater than resistance, so thrust is greater. So these are two possible options. So the conclusion is the correct option is this one. Okay, so now number 39. So in number 39 it states a person just supports a mass of 20 kgs. This is the mass which is 20 kgs suspended from a rope, like suspended from rope. What is the resultant force acting on the mass? Oh, okay. So let's see the weight of the mass, like the weight is acting in downward direction, which would be approximately 20 times 10, Newtons. And at the same time the tension is acting in upward direction. So 200 Newton is a tension force which would be acting in upward direction. So 200 Newton weight is acting in downward direction, and 200 Newton is a tension force which is acting in upward direction. So both the forces are acting in opposite direction. So the resultant force is 200 is in upward direction and 200 is in downward direction. So the resultant is 0 Newton. So 0 Newton force. A particle P is moving in a horizontal circle O. P moves at a constant velocity, speed v. Okay, which statement is correct? A force of constant magnitude is acting in the same direction as v. It means there is a constant force parallel to this. A force of constant magnitude is acting towards this one. Okay, let's draw them one by one. So in option A there is a force which is acting in this direction. In option 2 it states one is acting in this direction. The force on P varies in size as it moves around the circle. It means there is a varying force, maybe sometimes in this direction, like there is no resultant force acting on P. This is the third option. Okay, see, the constant speed means when there is a constant speed, it means the like the resultant force acting on it is 0. So resultant force acting on a 0, that's why object has constant velocity. So we are going to consider this option because there is no resultant force acting on it. Object moving along a circular path will feel some centripetal force which would be acting in inward direction. As a reaction force, suppose the red one is a centripetal force. So in order to counter this force, there would be a centrifugal force which would be acting in outward direction. So the inward is centripetal force and outward is centrifugal force. So resultant is 0. Then object we can move with a constant speed or velocity. Number 41. A tractor pulls a tractor pulls a trailer at a constant speed. Constant speed means again the acceleration is 0. When acceleration is 0, resultant force is 0. So constant speed means acceleration is 0. Acceleration is 0 means resultant force is also 0. The tractor exerts a forward force of 600 newtons. So forward force is 600 newtons. 600 newtons. Suppose okay, 600 newton is acting on it in a forward direction. What is the force exerted by trailer on tractor? Okay, so tractor is actually pulling in a forward direction. So 1600 newton, this one is 1600 newtons, which is acting in forward direction. So we know that the resultant force is 0. So it means it is countered by the same amount of the force but in opposite direction. So 1600 is in forward direction, means 1600 would be in backward direction as well, like this. So we can say the correct option is 1600 in backward direction and the rest of the options are incorrect.